Lesson 11.2.1 Linear Models, Answering Various Types of Questions Algebraically. Many people make small items at home to sell at craft sales or on eBay or other websites. In some cases, it is easy for them to determine their costs and revenues. For example, Jenna makes scented oil lamps. The fixed costs for her lamp-making business are $1,100 per month for rent and utilities. The materials that she needs to make one scented oil lamp costs $4.50. Jenna sells each lamp for $10.50. Each month, Jenna sells all the lamps that she makes. Jenna would like to earn a profit by selling her lamps. Jenna will only earn a profit when her revenue, or the total amount of money that she collects from sales of her lamps, is greater than the total costs of her lamp-making business. Our question is, how many lamps must Jenna make in 1 month in order to earn a profit? Some of these terms are summarized on the right in the language tip. Fixed costs are costs that are the same every time period, for example, rent. Revenue is the total money collected in sales, and profit means the total revenue is more than the total costs. So for this example, we are going to let X equal the number of lamps produced in 1 month. We also let capital C equal Jenna's total cost for her lamp-making business for 1 month when she makes X lamps. And we're going to let capital R equal Jenna's revenue for her lamp-making business for 1 month when she sells X lamps. We will find functions for cost and revenue. For this situation, these are linear models, meaning these mathematical functions that we are going to find are linear models. Most of the questions we will ask can be answered from a table or graph, but we will also use the functions to answer these questions algebraically, meaning we're going to be looking at equations. This is faster, meaning using the equations is faster and more accurate than making tables and graphs to estimate answers to such questions. Graphs, the estimation can be pretty difficult. Tables just takes too much time. So number 1, suppose that Jenna rents a building for her lamp business. This month, Jenna does not buy materials or make any lamps. What is her cost in question A for this month? So she's not buying any materials, she's not making any lamps, but what is she doing? She is renting a building. So how much is her rent for this month? As we saw up in the paragraph that started this, it is $1,100 per month. So this month that they're referring to, her cost is the $1,100 in rent. Part B, what is her revenue this month? Well, notice she didn't make any lamps. So if she didn't make any lamps, that means she didn't sell any lamps. So how much money did she make in revenue? $0. So $0 since she sold no lamps. Continuing to number 2, suppose that Jenna makes and sells exactly 1 lamp in a month. So now here's a different scenario. Let's say that she has this particular month and she's just going to make and sell 1 lamp. What is her cost for that month? Well, we have to think of what does she have to pay even if she makes no lamps? $1,100 in rent. But now let's think about what is the cost to make 1 lamp. Going back to the previous page, the materials that she needs to make 1 scented oil lamp cost $4.50. So it costs $4.50 to make 1 lamp. So $4.50, and you could say that's in materials. So what is her total cost for that month where she makes and sells 1 lamp? $1,100 plus $4.50, that's $1,104.50. And then part B, what is her revenue in that month. Well, she sells one lamp, and we're told on the previous page that when she sells a lamp, she sells them for $10.50. So sells one lamp, so the revenue is just the $10.50 that she gets from that one lamp. So now let's organize some of what we found so far in this table in number 3. Fill out the table below to calculate Jenna's monthly costs and revenue. So we've already done for 0 units, that's the first row. So x equals 0, the cost was $1,100, and the revenue was 0. Then the next row for 1 unit, that's when x was equal to 1. The cost we said was $1,104.50. And then the revenue was $10.50. Now the next row, here we have 2 units. So the cost would be $1,100 for rent plus 2 times the amount that she needs for materials for each lamp. So this would be $1,100 plus 2 times $4.50. That's going to give you $1,109. And then for the revenue, if she sells the 2 lamps that she makes, because she sells every lamp that she makes, this would be 2 times $10.50, and that's $21. So what we're doing here is similar to what you saw in lesson 11.1.2, where you're just trying to get a sense of the situation by writing down some information and seeing if you notice a pattern. So now let's do the same thing for 3 units. What would the cost be? She always has to pay $1,100. And then she has to take the number of lamps she sells, 3, and multiply by the cost to make each lamp, $4.50. So this would be $1,100 plus 3 times 4.50, and that gives you $1,113.50. And then what would the revenue be? It would be 3 times $10.50. Because she sells each lamp for $10.50, and she sold 3 of them, that's $31.50. Don't forget, you don't want to write 31.5. You want to think this is dollars and cents, that's 31.50. And then finally, for 4 units, this would be $1,100 plus 4 times $4.50. So $1,100 plus 4 times $4.50, and that gives you $1,118. And then what's the revenue? 4 times $10.50, which gives you $42. Okay, so now number 4. Suppose that Jenna makes and sells X lamps. This is the point of algebra. You just did some things thinking about 1 lamp, 2 lamps, 3 lamps, 4 lamps. But now what if it was just any amount of lamps? X. Part A, give a function that will compute the total cost of producing X lamps. And this is also just like what we saw in lesson 11.1.2. Take a look at the middle column where we were calculating the costs, and just notice where the numbers were changing. The 1100 stayed the same, the 450 stayed the same. But when we had x equal to 2, that was the number that was multiplied by 450. When x was equal to 3, that was the number that was multiplied by 450. When x is equal to 4, that was the number that was multiplied by 450. So x is the thing that is being multiplied by 450. So your cost is 1100 plus x times $4.50. And just like we did in 11.1.2, we can think of this as C equal to 1100 plus 4.50 x, where we usually write the number times the variable x. And then how about a function for revenue? Here, notice again what we did in the last column. When x was equal to 2, it multiplied by 1050. When x was equal to 3, that's the number that multiplied by 1050. When x was equal to 4, that was the number that multiplied by 1050. So revenue is just take the number of lamps you sell, x, and multiply by 1050, which means R is equal to 10.50x. So both of these are the exact same sort of equations that we saw in 11.1.2. Number 5. One of the equations in the answers to question 4 represents a direct proportionality. So while both of these equations could have come from section 11.1.2, one of these two could have also come from section 11.1.3. Which equation represents a direct proportionality? And for that, I would just remind you that this has to be in the form y equal to m times x. So of those two, which is the only one that has a number times x and then nothing else? That's the revenue equation. Because the y-intercept is 0. You just have a slope times a number. R equal to 10.50x. Okay, so now use these functions for cost and revenue to answer the following questions. Number 6, if Jenna makes and sells 200 lamps in 1 month, what are her costs? Well, we have that cost was equal to 1100 plus 4.50x. So 200 lamps, remember that the number of lamps is a value of x. So the 200 would go in for the x. So the cost would be 1100 plus 4.50 times 200. You can type it in like this into your calculator, 1100 plus 4.50 times 200. Your calculator knows the order of operations, but you could also multiply 450 times 200 first, and then add that to 1100. Either way, you're going to end up with a final answer of $2,000. So her costs are $2,000. What is her revenue? So here we start with the equation R is equal to 10.50x, but then the revenue would be take 1050 for each lamp times the 200, the number of lamps, 10.50 times 200, she makes $2,100. Part C, were Jenna's revenues more than her costs for the month? Yes. What we got for revenue, $2,100, is more than $2,000 for costs. So revenue is more than cost. So did she make a profit? Yes, she made a profit of, how would I find that? Profit is just revenue minus cost. $2,100 minus $2,000. So she made $100 in profit. In questions 7 and 8, use the functions for cost and revenue to set up an equation that represents the given information. You will be asked to solve the equations in questions 9 and 10. Check your answers by substituting into the original equations. So 7 and 8, we are just writing down equations. 9 and 10, we are actually going to solve those equations. So number 7. 1 month, Jenna's revenue was $2,016. Set up an equation that reflects this information. So we have an equation to start with. R is equal to 10.50 times x. What they're telling us in number 7 is not a number of lamps, but a number of dollars for revenue. So the equation would be the $2,016 in revenue equal to 10.50x. Okay, that's just the equation that we're writing down. Number 8. Another month, Jenna's cost was $2,090. Set up an equation that reflects this information. So here, cost was $2,090. We have a cost equation from before. C is equal to 1100 plus 4.50x. But now, again, we're not replacing x with the number of lamps. We're replacing capital C with what was the cost for this month. So the equation would be 2,090 equal to 1100 plus 450x. Okay, so those are our equations. Now number 9. Solve the equation from question 7 for the number of lamps sold, which means we want to take the equation 2016 equal to 10.50x, and we would like to know what is the value of x. This is going to use things that we saw over the previous sections, opposite operations. So what is happening with the 1050 and the x? They are being multiplied. We need to do the opposite of that to figure out what x is equal to. So what is the opposite of multiplication? It's division. Which means x is just equal to 2016 divided by 1050. So take 2016, divide by 10.50, and you should get 192. So 192 lamps. That's the answer for number 9. How would you check that that's true? Take that number and plug it into the equation you had in number 7 and just check. What is 10.50 times 192? It's 2016. So now number 10. Solve the equation from question 8 for the number of lamps made. I'm going to write some of this stuff off to the left just to give myself some room. You're going to start with the equation 2090 equal to 1100 plus 4.50x. And we again need to use opposite operations. So here, we don't want to divide first. The reason why is we'd have to divide every single number that we see. So that's a little bit complicated. What's easier is if you add or subtract any constants, which are numbers that aren't attached to a variable by multiplication. The only number that's on the right-hand side that's not attached by multiplication is the 1100. So I'm actually going to get rid of that 1100. But how would I do that? Take a look at the sign of 1100. In the original equation, it's positive. What's the opposite of a positive number? It's a negative, which means subtracting is how we are going to get rid of that from the right-hand side. So 2090 minus 1100, that leaves us with 990, is equal to 450x. So now I'm going to rewrite that equation. 990 is equal to 4.50x. So now how do I get x by itself? This is now just like what we did in number 9. I'm going to use division. Divide both sides of the equation by 4.50. And when I do that, that gives me that x is equal to, because the 4.50x divided by 4.50, remember you're doing an opposite operation to get rid of the number. The x just stays where it is on the right-hand side of the equation, and 990 divided by 4.50, that's 220. So that means the answer for number 10 is 220 lamps. How would I check that that's correct? Take it and plug it in for x in the equation from number 8. What's 450 times 220? And then add that to 1100. Just check that you get back to 2090. Number 11. Work with your group to set up an equation that would describe Jenna breaking even in her lamp making business. Breaking even means that Jenna earns the same amount of revenue that she pays in costs. So what this really means is what she gets from revenue is the same as what she pays in costs. So she earns no profit. So you can also write profit is 0. So to figure this out, you have an expression for revenue. It's 10.50 times x. You also have an expression for cost. It's 1100 plus 4.50 x. So this is the equation that you could use to figure out how many lamps she needs to sell to break even. So that's the setup for the equation, just setting those two things equal to each other. So now if we go to the next page, number 12, once you've agreed with your group on the break-even equation, try to solve it. Remember, what operation you perform on the left side must also be performed on the right side. So you can also solve this using opposite operations. When they say try to solve it, that means we want x equal to some number, and we want a number of lamps. So start with what we wrote down for number 11, 10.50x equal 1100 plus 4.50x. The way that you want to solve this is try to think of anything that's being attached to x by multiplying. You want them all to be on the same side of the equation. It's kind of like just separating teams. Okay, so we've got the x's, and then we've got the things without x. So 1050 times x, that has an x. 450 times x, that also has an x. I would like both of them to be on the same side of the equal sign. So I need to move something. It would make sense if I move the 4.50x over to the left. And how would I do that? Take a look at the symbol that is just in front of the 4.50x. It's a plus. So what's the opposite of plus? It's subtract. So I need to subtract 4.50x from both sides. Okay, so now, what am I left with on the right-hand side? Well, I had 1100 plus 4.50x, but now I just subtracted 4.50x. So all that's left is the 1100 that I began that side with. And now what do I get on the left-hand side? Well, I could subtract the numbers, 10.50 minus 4.50, but they would then still be attached to an x. And this is just the idea of if you have 5 apples and you subtract 3 apples, you now have 2 apples. It's a number of things. So in this case, I have 10.50 x's minus 4.50 x's. And remember, x stands for lamps. So this just becomes 6 times x. Because 1050 minus 450 is 6. So now I have 6x is equal to 1100. So 6x is equal to 1100. And then what would I do next? Since 6 is being attached to x by multiplication, I have to do the opposite of that, which is division. So x is just 1100 divided by 6. And if you use a calculator for that, 1100 divided by 6, you get approximately 183.333 lamps. But now, we've been using decimals a lot in this class. Does it make sense to say 183.333 lamps? Can you have a decimal amount of lamps? No, a lamp is either there or it's not there. So really this is just 183 lamps. How would you see if you're correct? Take x equal 183 and plug it back in for x in the original equation. And just see if your revenue and cost are equal to each other. Don't forget that you rounded here, so you just want them to be close enough. Okay, let's see another example sort of like that. Alicia's cell phone plan costs $10, and she is allowed to get 200 text messages each month. She has to pay $0.25 or 25 cents for each additional text message. She could switch to the unlimited text message plan, which costs $20. Define x to be the number of texts, so we're going to say that x is the number of texts, over 200 that she sends each month. So number 13, write a function that computes the cost to send x text messages after she has already sent 200. So here you can think of this like the cost that we had for selling lamps. There's a fixed cost, which is $10 that she has to pay. And then she has to pay extra for any text over 200 texts. So if she sends X amount of those texts, she has to pay $0.25 times that number. So in this case, C is equal to 10 plus 0.25x. To verify that this is correct, if you're still not sure, try thinking of what if she sends one more text than 200? What would her cost be? What about if X was 2 more texts? What would her cost be? This is kind of like how we start at the beginning of this lesson. All right, number 14. 1 month, Alicia sent 300 text messages. For that month, what is the value of X? Remember that X is the number of texts that is over 200. So 300 is how many over 200? It's 100. So here X is equal to 100. She sent 100 texts too much. So now number 15, use your cost function to compute the cost of sending 300 text messages. Well, that would be C is equal to 10 plus 0.25 times the 100 extra texts that she sent, which then becomes 10 plus 25, which is 35. Number 16, given your answer to question 15, does it make sense for Alicia to stay with the 200 text message plan? Okay, well, how much does it cost? If she sent this 300 text messages, $35. What would it be if she got the unlimited text message plan? It would only be $20. So if she does this a lot, not really. Maybe she just had a very busy month. So if she sends this much every month, it doesn't make sense. And I'm pretty sure that we're all familiar with this. Not only with texts, it could also go with internet usage or cable TV or anything where you've got a certain amount of costs, and then after a while you go, I wonder if it makes sense if I change my plan. This is the idea behind that. So, number 17 to finish, Alicia is thinking about switching to the unlimited text message plan. How many text messages would she need to send each month in order for this change to make sense? So she wants to justify this decision. Use the cost function to create an equation that you can solve to answer this question. So what we really have is the cost for less than 200 messages or texts. That was the $10. And then if she sends anything over 200, then that would be 0.25 times the number of texts afterward. So maybe instead of saying cost for less than 200 texts, we'll just say her original plan. Cost for original plan. That was C is equal to 10 plus 0.25x. And then what's the cost for the unlimited plan? That's just $20. C is equal to 20. So how would we know when it makes sense for her to change? This is the same idea as we saw as breaking even. At some point, these two costs are the same, but then one becomes more beneficial, the unlimited plan. So we just want to solve when is the original plan that she had the same as the unlimited plan as far as costs. And then once we answer that, that'll tell us how many texts she would need to send for it to make sense. So this is just like earlier equations that we've seen. Let's subtract the 10 first. That gives you 0.25x is equal to 20 minus 10, which is 10. And then giving myself some space, 0.25x equal to 10. I need to divide by 0.25. And then that tells me that x is equal to 10 divided by 0.25. That gives me 40. And remember that 40 stands for the number of texts above 200. So she would need to send 200 plus 40, or 240 texts. That would then justify it. If she sends 240 or more, it makes sense if she has the unlimited plan. And of course, if there was a month where she sent 300, this probably makes the most sense. All right, and then to finish this lesson, the word for this lesson is text.